Wonderful. So it's great to be here today talking about our project. As I was last, I assumed that quite a lot of the background would have come before. So I'm going to sort of focus more on what we're going to be doing in the project rather than the rationale for the project. The other thing you'll notice is our project doesn't have a nice snappy title at the moment. So as you go through the talk, if any sort of nice snappy titles come to mind, place them in the chat because they'd be greatly appreciated, because this is a bit of a mouthful. So our project involves University of York. So I'm based at the University of York. I'm sort of joined by Colin Brown at the University of York. Then we have Lorraine Maltby and Andrew Beckerman at the University of Sheffield, and Sim Reaney at Durham University. And we have, at the moment, we have 8 partners involved in the project. So they're at the bottom there. So I think there's some common names there with some of the other projects. And we are finding that over the last few months, as the project's got a little bit of media coverage, we have had some people contacting us. So there's a number of organisations involved in the project is growing. And if people, particularly in the Yorkshire region, are interested in joining, then just drop me an email at the end. I'd be quite happy to chat about getting you involved. But basically what we're trying to do is deliver a new catchment-based approach for assessing and managing chemicals in the UK environment. So our idea is that we want to develop an approach that begins to think about mixtures of chemicals, so moving away from the current approach where we take single compounds at a time. There's been discussion previously about the interactions of chemicals and co-stressors. So we want to begin to think about how co-stressors impact ecotoxicity of substances, and then begin to think about endpoints that actually have some meaning. So beginning to think about what the impacts of these chemical mixtures and co-stressors are on the structure and functioning of species assemblages in English rivers. We aim to do this at very high spatial and temporal resolution. And again, I think this picks up on some of the comments and discussion earlier that we can't really consider freshwaters across the UK as average. So we need to take into account the fact that these systems vary. The project is going to obviously look at the current situation, but like some of the other projects, we also want to look to the future. So we want to think about how global megatrends such as climate change are going to impact the sources of chemicals, the use practices of chemicals, the fate processes of chemicals in the environment, and what that means in terms of exposure and effects. And what we want to really achieve at the end is to deliver a framework that allows us to begin to identify hotspots of risk. And that will mean that we can begin to target interventions at points in the system where they're going to really have impact. And if we can do that, what we hope is that will allow us to continue to use the chemicals that we need in our day-to-day lives, but in the same time we're protecting the biodiversity of our river systems. So this is a diagram just illustrating how the framework works and the overall concept of the project. So on the left there, we take information on land use within a catchment, climate change information, catchment properties. We bring that together to characterize what the river systems within that catchment look like, to characterize what the use of the chemicals within that catchment are, and how the patterns of use happen in the catchment. And then using models, we will estimate concentrations of different chemicals within the catchment at quite high resolution. We'll also estimate concentrations of some of these toxicity modifiers. We'll have models for estimating ecotoxicity to species that actually occur in UK freshwaters. And then using ecological models, we'll be able to model what the community structure is going to look like. That data then will feed into species sensitivity distribution modeling approaches and food web modeling approaches to begin to characterize what the impact of the chemical mixture and the co-stressors are at a particular point in the catchment on biodiversity and ecosystem function. So that's the general idea. We'll be developing and demonstrating the framework using 9 catchments based in Yorkshire. So these cover an area of about 11,000 square kilometres. In terms of their hydrology and geology, we think they're a really good set of case study catchments. They represent about 86% of rivers across the UK. The rivers or the catchments are listed here. So you can see in the top left of the map, we've got the Swale, the Ure, the Nid and the Wharfe. So these are catchments in sort of very upland, rural areas that have market towns, probably quite a lot of sheep farming. So this might be something where there'd be overlap with Penny's project. As we move down, we then move into the more industrialised area of Yorkshire. So we have a lot more industry in those areas. We have large cities like Bradford, Leeds, Sheffield, and the systems are much more heavily modified. And then as we move towards the east, we have the Derwent. So the Derwent is much more arable. Again, it's very rural, and again, it's dominated by market towns. So we think this system is really good in terms of the different land uses and the different chemical profiles that are likely to occur across the catchments. In terms of the biology that we'll be looking at, our focus is on invertebrates and algae. So we'll be doing work on laboratory work on around 8 different invertebrate species and a similar number of algal species. And we'll be selecting these species to coincide with species that actually occur in UK rivers, and also cover a range of different traits. And that will allow us to begin to understand the relationships between species traits and sensitivity to different toxicants. The study is going to focus on 30 to 40 chemicals, and the plan is to focus on chemicals that are of actual concern in the catchment. And we've already started work on this. We started this back in November. We've already had a workshop with stakeholders where we started to sort of begin to bring a list of, I think it's about 300 different chemicals down to a manageable number. And we're now very close to having our final list of substances. But these substances will be selected to come from multiple sources. So it'll include the things that Benny has talked about, so things like the veterinary medicines. So there we'll be probably looking at antibiotics, antifungal agents, anthelmintics and other parasiticides. We'll be looking at arable use pesticides, so looking at selected insecticides, herbicides, fungicides. We'll be looking at diffuse things from traffic, so things like polycyclic aromatic hydrocarbons are likely to be on the list. We'll look at personal care products, so things like some of the preservatives that are used in the household chemicals that we use on a day-to-day basis. We're likely to include some UV filters, so this could be particularly important in the Wharfe, for example, where you've got Ilkley, which is one of the proposed bathing water sites. We're beginning to recognise that pet medicines are becoming more important. So I think Penny talked about the number of livestock species. We now have 22 million cats and dogs in the UK, and concentrations of a range of pet treatments for flea treatments, for example, are beginning to be detected downstream of wastewater treatment work. So we're going to look at what the potential impacts of these molecules are. And then we'll be looking at pharmaceuticals. And again, there we'll probably be looking at antifungal agents, antibiotics, and some of the NSAIDs, for example. So it'll be a real mixture of substances. And I think listening to the previous presentations, there will be overlap in the substances that we're looking at and what some of the other projects are looking at. The project's going to be delivered over 4 years. So this is just a diagram showing the work packages and the interlinkages between the different work packages. So we're just coming to the end of work package 1, which has been all about prioritisation of chemicals of concern. As I said a moment ago, we're almost at a stage now where we have the chemicals that we'll be taking forward in the rest of the project. We'll then be moving to a series of work packages that will happen in tandem. So in work package 2, we'll be doing work similar to some of the work that's been discussed in the previous presentations, looking to establish the current use and use patterns of chemicals, but also looking to the future to begin to look at what future use might look like in the catchment. We'll have a work package looking at developing exposure models. That will be, the aim there will be to develop a model that allows us to estimate concentrations from multiple use types at very high spatial and temporal resolution. And we've got a monitoring program that will be running as part of that work package to generate the experimental data that we'll be able to use to evaluate that modelling framework. In terms of the ecotoxicity, the ecotoxicity studies will be done in work package 4. There we'll be doing studies on our 30 to 40 test chemicals, looking at impacts on these species that actually occur in UK rivers. And the idea there is to develop mode of action species relationships for chemicals within a particular mode of action. The data from those work packages then will feed into the ecological modelling work package, which is work package 5. Here we'll be using HSSD modelling and food web modelling to model the effects of mixtures of chemicals across our catchment. And using the outputs of that modelling, then we'll be able to begin to develop hotspots of risk and also the drivers of that risk. And that will then allow us to identify interventions that could be put in place to mitigate those risks, either currently or thinking into the future as the climate changes, how we could mitigate the environment as we move forwards into the future. Co-design and co-delivery, like all of the other projects, is really key to this study. So at each step in the process, we will be involving the partner organisations and other organisations to get their input, advice in the design. And we've already had a workshop, as I say, just before Christmas that was around the chemical selection and prioritisation. So this project then, as well as delivering this framework, is going to, I think, deliver some quite innovative science. So like some of the other projects, we will begin to think about how chemical exposure might change in the future, how use might change in the future. We'll have this high resolution system-based mixture exposure model. We'll have models for estimating the effects of toxicity modifiers, such as pH, on bioavailability and effects of substances on organisms. We'll have read-across approaches that allow us to extrapolate effects across species for chemicals within a particular mode of action. And we'll have models for assessing the impacts of chemical mixtures and co-stressors on biodiversity. And taken together then, I think hopefully what we'll be able to deliver is actually a framework that allows us to sort of assess and manage chemicals in a much more scientific way. So hopefully it will allow us to transform the way that chemical assessment is done at the moment in UK rivers. That will allow us to help halt the decline in UK freshwater biodiversity. But at the same time, hopefully it will mean that we can continue to benefit from the many benefits that chemicals provide to society. So hopefully that gives you an overview of what we're planning to do. My email is at the bottom there, so if anyone has any questions or wants to get involved in the project, just drop me a line after the meeting and I'd happily discuss things further. Thank you.